Hello my dear champions, it's time to solve the sure shot question from the chapter Continuity and Differentiability for your PU2 exam. Very clearly I'm mentioning for your PU2, these are the sure shot questions from the chapter Continuity and Differentiability. Let's look at these questions very quickly. The first one is based upon a question of definition of continuity. This is worth, I hope you all know it, 4 marks. This is worth 4 marks, right? How do you solve it? So they have given that the given function is continuous at the point x equal to 0, hence find the missing value of the variable k. How do you solve this? So for a continuous function, we know very well that limit of the function fx when x tends to 0 should be equal to f of 0. And we also know that for limit to exist, of course, my LHL should be equal to the RHL. Okay, so I can consider any one of them, or simply I can substitute in the function if it is possible over here, which it is. Clearly in this case, it's forming a form of standard limits of sine. Okay, let's substitute the value for this. I get over here as limit function fx is there, constant is 3/5, and over here I'm getting sine pi x upon x. That's something here, and x tends to 0, of course, and this is what f of 0 is given as 2k. So write this as 2k. Clear? Write this as 2k. Now how can you make this same? Of course, by multiplying it with pi over here, and since you are doing something extra, you have to remove that as well. So pi and pi. Now you check the constant 3/5 comes out, and now you have the limit of this sine pi x upon pi x when x tends to 0 is what? Equals to 2k for the continuous function. All right, now sir, the formula is for sin x by x, but if you substitute pi x as y, if you substitute pi x value as y, basically x value as y by pi, x value as y by pi. Okay, think about it. When x is 0, even y will be 0. When x is 0, y will also be 0. Okay, when x is 0, y will also be 0. So I can transform this if you want, sine y by y and limit y tends to 0. Your choice, but not required actually. So if you apply this limit, this whole thing transform into what? This whole thing transform into simply 1. Hence my answer can be concluded over here is 3/5 into 1 is equals to what? 2k. I need to find the value of k, so I'll move this 2 on this side. 3/5 into 2 is 10, and that is exactly the value of my variable k worth 4 marks. Okay, k value is 3/10. This question comes in section E. Section E, which is the second problem, worth 4 marks. Okay, the alternative of this question will be what? The determinant problem of 4 marks. 4 marks, very easy question. Do it, prepare it, and get it for free. Okay, with little bit of efforts, of course. And one more question which is there, a short question. This is worth 5 marks. This is worth 5 marks. Again, these are, of course, the chapter is worth 17 marks in total in your boards, but these 2 questions are guaranteed. Means short question means a question like this will come for sure. The first was on the definition of continuity, and this is on the second order derivative. This is on second order derivative. A question on this in section D. This comes in section D. Very common problem. For many years they've been asking a question like this. Okay, highly likely to make a change, but if it is the same pattern being followed, yes, we can expect this. How do you solve it? You have y. Let's try to find y1 first. What is y1, sir? y1 is the derivative 1. Yes. So y1 will be what? Your 1 upon root of 1 minus x square. Take on this side, you'll get y1 times of 1 minus x square inside the root equals to 1. Now what are you gonna do? Squaring both sides, you get y1 square 1 minus x square equals to 1. Now you differentiate to get the second derivative. When you do that, you'll get here, if you differentiate over here, you're gonna use what? The product rule. This will become 2y1 for the derivative of y square, and differentiate y1 again, you'll have y2, and this is as it is. 1 minus x square is as it is because we are using the product rule. And next you have a plus sign, so put a plus sign over here, and this time keep the y1 square as it is. and differentiate what? The bracket, the other part, which you get as minus 2x. The right hand side is a constant, so 0. RHS is a constant, so 0. Okay, check, you have something common. You have 2y1 actually is common. You get here y2 times of 1 minus x square. Over here you'll have only y1 into minus x left equal to 0. You can move this on this side, it will become 0 simply. So answer can be written as y2 times of 1 minus x square and minus x y1 is 0. Now you might, if somebody is thinking, sir, this is not the answer, let me reframe it for all of you. Write it again, 1 minus x square as it is in the bracket. Y2 means second derivative, so d square y upon dx square minus x, y1 means first derivative, so dy by dx. And now you can see that it is clearly the expression they were asking us to prove, the equation they were looking for. So have a look. And it is your 2 short question from the chapter Continuity and Differentiability. Of course, subscribe for more such videos if you want more such classes like this, where I can give you exactly what question you can expect in the exam for a PU2. Let me know that in the comment of this particular class. And for all the information of all the updates, all the class notes, you can simply join the WhatsApp channel. For the link you'll be finding in the video's description. Go join that and get all the notes for free, of course. And subscribe to the channel for more such content and for more classes and help in your preparation of PU2, KCET, Comet K, all this examinations. Okay, that's all for today in this particular video. See you again in the next one. Till then, take care. Bye bye.